Hello, it's Justin, Sietz of Immunity. I'm going to be talking to you today about our distributed process monitoring tool, ElJefe, also known as the BOSS. What ElJefe does is intercepts process creation calls, analyzes the binaries that are involved in the process creation call, both the parent and child, and ships it all off to a distributed log server so that you can go through the data later on. How it does this is there's an agent that's installed on the end workstations. This agent's supported from Windows XP, both 32 and 64-bit, all the way up to Windows 7, 32 and 64. And this little agent's job in life is to intercept these calls, package up the data, and shoot it off to our web application. The web application is basically where you're going to spend all of your time with ElJefe. And this is what we're going to do today, is we're going to go through some data that's been captured from a host that's been exploited in various ways, and I'm going to show you how some of the data you can see in the web app is useful to you in your enterprise. So let's go ahead and we'll log in first. The default is always ElJefe and ElJefe for username and password, and you're going to be shown this screen. And really everything is controlled through these tabs at the top. So you have stations, which is the computers that have ElJefe installed, binaries, which are the binaries that both created processes or were children of a created process, events, that is an actual process creation event, our ever so handy intrusion tab, which will run through different heuristics to try to determine if you have been intruded. Our data tab is used for debugging purposes. By clicking drop all, that will in fact drop all of the data from the ElJefe system. This is useful when you first start debugging the system, but be careful with this feature later on. And the XML log will simply show you what the actual XML traffic is from the end agents. And the Docs tab will show you our very handy user's guide. So let's start by taking a look at stations. So if we click Browse, we're going to see that we have one station in our database. It's going to give you the host name, the IP address, and then binaries and events that are corresponding to this particular station. By clicking on Events, we're going to get a listing like this. Along the left-hand side is going to give you the date. It's going to tell you when the event actually happened. The parent binary is who created the process. The binary column here is going to actually tell you what binary was created, what process was actually started. It's going to give you command line flags. And it's also going to tell you the username. And, of course, if you're going through all the events in the system, it's going to tell you what station along the right-hand side. By clicking on the event, we'll click on the date column. This is actually going to tell you what happened during this process creation call. So we can see the username, when it happened. We can see the binary that was started here. Then we can actually see this PID tree, which will tell us as processes create more and more child processes, this tree will begin to expand. So you can see who is creating what all the way down through a call chain. Right below that, we see the binary SHA-1, which is useful if you're correlating any of the SHA-1 hashes found in the ElJefe database with any other product that you use, whether it be AV or an event correlator. Very useful. We have the parent binary that started it, the process ID of the parent's hash, and again the command line, and we also log the privileges. So you can actually see what processes are executing at what privilege. Now this might be useful from an auditing perspective, whether you want certain processes using certain privileges or not. This can also be useful if you're taking a look at some post-exploitation work. Did anybody actually increase any of the privileges or decrease any of the privileges on a particular process while they were mucking about your systems? And then further down here, you can actually see any of the child processes that were created. So let's take a look at actually we can take a look at this example one, JP2L launcher. We're going to take a look at that binary record. So again, you're going to see which station owns this binary, its SHA-1, its size. The architecture is going to tell you, is this a 32 or 64-bit executable? And we actually take the code section, the actual executing code section of this binary on disk, and we hash it as well. So you're able to actually tell between different versions of the same file, does the code section actually change? So for example, if an attacker came in and replaced this launcher file with a copy of their own, you could actually see that this code section has changed. you would also see, obviously, that the binary hash has changed. So the next part is the actual code entropy. Now, the entropy is a calculation we do, and a very low entropy typically indicates a Trojan or something that has very simple code, typically a receive loop, kind of download shell code and execute it. Something that's normal is typically in the 5 to 6 range for entropy. You'll find that for normal binaries or normal Windows executables. And typically anything higher than 6 or 7 is indicating malware or something that's been packed, compressed, or encrypted. So these are all very useful for us as we're looking at post-intrusion signatures. And here's an actual dump of the code section. So if you really wanted to, you could take all of these bytes, run them into an assembler, and you'd actually be able to see what the assembly code is for this particular code section. All right. So now that we've taken a look at a binary and we've taken a look at some events, you can see how easy that was. It's basically 2 clicks, and you're going to be able to see a lot of very useful information. And the next step, of course, is to use the intrusion tab. But as with anything, it's always better to be able to look at these things manually before you can trust what the intrusion tab does. So we're going to take a look. Let's just walk through some of these processes. So we're going to see in this screen that Internet Explorer was fired up, that it started up Java at some point. And then a particularly interesting one is Java here on this line has actually started a cmd.exe. Now this is, of course, should be setting off the alarm bells. Anytime Java is firing up a cmd.exe from Internet Explorer, one may think that there is a problem. So as we scroll down even further, we can see that that cmd.exe is actually firing up a binary down here, MSVC2696, right off of the desktop. Further down, we can see MSVC2696 starting another file called MS1103.264. So what this is telling us is that this particular client-side exploit coming in through Java has fired up a command shell, and now it's running another command to actually perform a local privilege escalation attack, which is MS1103.2. And we can see that it then creates some more processes, and all the way down the chain, you can see that there's continual badness. As we get to the bottom here, we can see down on that command, the second last line, that the final cmd.exe that was created then ran net start HCN, which is the rootkit that is shipped with Canvas. So you can see here is a prime example of how a client-side exploit ultimately results in an advanced persistent threat being installed on the end machine. And this is very easy, and in less than 30 seconds we were able to say something looks suspicious all the way to something definitely does not look right. So going from here right to our intrusion tab, we can go, all right, what can we actually search for? So basically you can give it a date range, so you can tell it from a particular date to a particular date. Or you can just say, I want to know every single time that a particular condition has been met. So we have privileges, non-system to system, which is obviously a privilege escalation attack. We have a call chain, Internet Explorer to Java to CMD, which is clearly illustrating what we just ran through. We have executing parent of LSAS, which should never occur, and if it does, you'll want to know about it. And then we also have suspicious entropy and suspicious flags. So let's just take a look at this call chain here, and we'll see that it clearly picked up the fact that in a call chain where Internet Explorer is a parent and Java is a child and CMD is a child of Java, we want to know about it, and it actually picked it up quite clearly. We can also take a look at, let's see what entropy was suspicious on any one of those binaries. So we can see both of these callbacks that were created right before the advanced persistent threat was loaded. We can see that the entropy was very low. Now again, if we ran this all through an assembler, we would see a download receive loop where we're going to get some shell code and we're going to execute it. And this is also why the entropy is very low with this executable. So in less than 15 minutes, we've been able to see how ElJefe is able to capture all of this information both for forensics use and also for post-exploitation, being able to walk through how an attacker got on your system, what they did when they were there, and anything they may have loaded. And we're also able to see some of the automated stuff that ElJefe will do in order to pick up anything suspicious. The beauty of the ElJefe system is that it's open source. So if you wanted to extend any of the intrusion heuristics, you are more than welcome to do so. And if you have any questions about extending ElJefe, installing it, using it, any bug reports, or you'd like any further information, you can contact the ElJefe team at ElJefe@immunityinc.com. I thank you for your time today. Happy hacking.